Hello everyone, welcome to this video. My name is Felman Garcia. In this video, I am going to answer this activity. This activity is to prove that the following grammar is ambiguous. Ambiguous means if the string can be derived in multiple ways that will lead to the different parse trees. The expressions to derive in the grammar rule is A plus B plus C. In this expression, we can create combinations of operations such as parentheses A plus B plus C and A plus parentheses B plus C. We can say that our expression can be derived in multiple ways. Now, let us do the derivations of the two combinations of operations by following the given grammar rule. Since the parse trees are given on this activity, we can follow this to start our derivation process. Let's start to derive these parentheses A plus B plus C. Our first step, we're going to start with S. As you can see in our parse tree, first parse tree here, start with S. So let's implement the first step. S derive A means S can be replaced by A. Next step, apply A derive A plus A. So meaning we started on S, we derive S to A, and then we are going to derive A derived to A plus A. A derive A plus A. So our string is now S derive A plus A. Next step, for the first A, this A, we are going to derive A plus A. For the first A, apply A derive A plus A step. So A derive A plus A. So our string now, or S, derive A parenthesis A plus A, then outside parenthesis plus A. So in this A, we derive A plus A, then plus A. Next, for this letter A, we will choose A as our ID. So for the first A, apply A derive ID. and choose A. So to apply that, A, derive A. So the format now of our string or S is S derive parenthesis A plus A plus A. Now for the second A, this A, so for the second A in our A plus A, so for our A plus A, apply A derive ID. So in that ID we will choose B. So let's apply that. A derive B. Now our S is S derive parenthesis A plus B plus A. Now for the last A, we will derive ID C. So for the last A, apply A derive ID. So where in that ID, we will choose C. So to apply that, A derive C. Now our S is now derived with A plus B plus C. So based from our parse tree and this operation, so this is our derivation. So to be able for us to get this operation. Now for the derivation number 2, so we will derive this parse tree. So S, we will start with S. S derive A, then A derive A plus A, then this first A will derive ID, and that ID is A. Now this A derive A plus A, then this A derive B, then this A will derive C. So let's do now the derivation. So the first step, start with S. Let's apply S derive A. Then step 2, apply A derive A plus A. So A derive A plus A. So our string or S will become A plus A. Next step, for this letter A, we will derive small letter A. So for the first A, apply A derive ID, and then wherein that ID is, we will choose A. So to apply that, A derive A. So our S now is A. S derive small a plus A. So meaning, so A derive A and then plus A. Okay. Next, for the second A, let's apply A derive A plus A. So where is this A plus A? So in this A, we will derive A plus A. Then this A will derive B. So but before that, we have to execute this A derive A plus A. So now our S derive A plus A plus A with parentheses. Okay. Next. So A derive, so A plus A. So A plus parentheses A plus A. Now next is we will derive this A derive to B. For the first A in A plus A, apply A derive ID, within that ID we will choose B. So to apply that, A derive B. So our S now, S derive A plus parenthesis B plus A. Next, for the second A, we will derive C. For the second A, apply A derive ID. So wherein that ID, we will assign C. Now let's apply that. So A derive C. So our S now, S derive A plus B plus C. So now we are finished. So we derive the two parse trees. Then we can say that the string A plus B plus C can be derived in two different ways, that is resulting in two distinct parse trees. We can conclude that the grammar is ambiguous. Then another reason why this grammar is ambiguous, because did not follow the what we call the operator precedence. If this grammar follow the operator precedence and the construction of B and F is group and ordered, so we can say that this is ambiguous. Now we can make this grammar unambiguous by reconstructing the grammar. So to make this ambiguous, construct A, construct A plus B, or B, wherein B derive ID, wherein ID derive, we can choose an ID whether it's A or B or C. So this is an ambiguous grammar rule, because if we are going to derive this and make a parse tree on this will create only exact one parse tree and one derivation sequence. Now, the ambiguous, in order for us to say this is ambiguous, the construction of B and F is group and the operations are ordered, and it follows the operator precedence. Parse tree of this grammar rule, ambiguous grammar rule, is if you're going to make a parse tree on this is the parse tree. So S derive A derive A plus B. Then this A derive A plus B, and then A derive B, and then B derive A. This B derive small b plus B derive C. So it follows operator precedence because the combination of this is like this: parenthesis A plus B plus C. So this is unambiguous because it follows the rules of operator precedence. The parenthesis starts on the left side, followed by the expression, and it follows the group, and the operations are ordered. That's why, so therefore I conclude that this grammar is ambiguous because the expression A plus B plus C can be derived in two different ways and resulting into two distinct parse trees. That's it. Thank you very much. I hope you understand. Thank you for watching.